So for our mass volume lab today, unfortunately, you aren't going to be able to do it yourself. You're going to have to watch me go through some of this. But I'll try to walk you through the process, and hopefully we'll get a little bit of a feel for how some of this stuff works. A lot of the equipment I think you're already pretty familiar with, but it's not the same, I realize, just watching your teacher do it. But it is the hand that we're dealt. Now, when you open up your assignment, you're going to find a document that's going to look similar to this. Well, really kind of exactly like this. And it's going to have some of the boxes that are going to be filled in already, and some that you need to fill in. Now, you don't need to fill them in with written answers. You're actually going to have to just drag the appropriate measurement to the appropriate box. So if you follow along right now, you can pause the video as needed to and just drag the measurements that we see into place. But as we go through this, I'll talk through that as well, and we'll try to make some sense out of it all. First thing that I want to do, I do want to measure some mass. There are three objects that the mass has not already been filled in for us, so that we'll start with those. And we are going to find the mass of the domino, the ping pong ball, and the screw. So when I turn on my scale here, there we go. Give it a second. You'll notice that our scales, right now it's currently measuring in grams. There's a button here that I can actually toggle between different units of measurement if I so desire. But I do want my measurement in grams, so I'll keep it there. And it's pretty simple, of course, technique. I'm going to set the domino on there, and I get a measurement, 12.90 grams. We'll get rid of the hundredths place, and so it'll just be 12.9 grams. And then I can fill that in into my data table, and I'm in business. Now you, again, I don't have to fill it in. You're going to just drag the appropriate quantity to the spot. Now, with these objects, we can go ahead and place them directly on there. If it were chemicals, however, we would be sure to put them in a container. Now, when I do the ping pong ball, you'll notice sometimes I set it here and it has a tendency to want to roll off. So what I'm going to do to combat that is I'm actually going to put this little tray on there. Obviously the tray has some mass, so I need to compensate for that. I could just write down the number and subtract the difference, or my scale's got a little button here. It's got the T on it. It stands for tare. When I press that button, it just re-zeros it. Okay, so now anything I put on there, like my ping pong ball, it's going to only read the mass of the ping pong ball, 2.9 grams. All right, so once again, I'll enter that into my data table, 2.9, and I'm going to do the screw. Now I can just go ahead and leave this as it's tared the way it is, go to re-zeroed, so it doesn't matter if I use the tray or not, so I might as well do it. And then I drop it on there, 6.4 grams. So now I've found the mass of the three objects that we're missing. The mass of the other objects are already listed there for you, so that is done. Next, we're going to move over to the third column, which is the volume by water displacement column. And there are a few objects that we need to find the volume that way. I'm going to try to tilt our camera. So you're not upside down. Get to see things a little bit better here. The first object that we're going to find by water displacement is going to be the Jenga piece. And as we talked about with water displacement, we have a known quantity of water. And we're going to add the object and see how much the volume increases from there. Sorry about the crookedness. It's going to be a little kittywampus, but we'll get the general gist of it. Here I've got a graduated cylinder. It's filled with water. It's just blue water with blue food coloring so you can see it a little better. It currently is at 120 or 110 milliliters. Now, when I put my object in, I'm going to put my Jenga piece in there. I'll drop around in there, try to carefully get it so it doesn't splash. And we say, uh-oh, it's floating. Well, that happens sometimes. And so right now, currently, everything that's not inside the water is not being measured. The space that is taken up or its volume is not being measured. So we have to submerge that Jenga piece. So I'm just going to grab another graduated cylinder and push it down here. We were at 110. Try not to get the graduated cylinder in there. And now we've jumped up to 136, it looks like. So it's going to be 26 milliliters, the volume for my Jenga block. So I'll write in 26 milliliters for my Jenga piece. Next, I'll do the golf ball. The golf ball, you'll see, won't fit in the same graduated cylinder. I got to use a larger graduated cylinder. It's important to remember, too, of course, that the different increments here mean different things depending on which graduated cylinder you are using. Okay. On this first graduated cylinder right here, each line was worth 2 milliliters. Each line in this larger one is worth 5 milliliters. And so it's important to keep that into consideration when you're making your calculations and measurements. So now I'm going to I'm at the 200 milliliter mark on this graduated cylinder. I'll try to carefully roll my golf ball in without spilling too much, because it does want to splatter. See it go in there. Now looks like we're up to 240. It was at 200. We've got a 40 milliliter golf ball. Last object that we are going to measure is going to be our screw. For this one, though, I'm going to use a smaller graduated cylinder. And it's important that you use the smallest graduated cylinder that you can. You're just going to get that much more accurate a measurement, accurate a reading. Also notice when I do this, I have to have the graduated cylinder deep enough with liquid that the object will submerge. In this case, it's going to be close if I'm not careful. So I have it at the 7 milliliter mark. All right, that should be enough to get my screw submerged. I'll try to drop it in there carefully so as to not spill. And from the 7 milliliter mark, it looks like we climbed up almost to the 8. If we read from the bottom of that meniscus again, it's probably going to be at the 7.9 mark, so 0.9 milliliters for the volume of my screw. The rest of the volumes are filled in, but now I need to direct my attention to solving the volume using some geometry formulas. Some of you are in geometry now, I'd imagine. I don't know if you've hit volume formulas yet, but I would imagine that you eventually will. And you see that there are 3 that I have not filled out numbers for. Those are the 3 that you will have to calculate. But I just want to go through the process for each of the different shapes, because for each shape there's a different formula, and the formulas are going to be listed up there for you. First of all, when you have a cubic object, okay, cubic object, the object that you're going to be calculating is going to be a metal bar. It's going to look like this. All right. Again, it's got 3 dimensions. It takes up space in that way. We'll do the domino here real quickly. Pretty cubic shape. Again, we want to measure a length, a width, and a height. So if I look here, looks like I've got, for a length, I'm going to have 5 centimeters. Width, I'm going to have, looks like 2.4 centimeters. And then my height, my third dimension, looks like a little over 0.5, probably 0.6 centimeters. So then I'll take out my handy little calculator and I'll plug in my numbers. This formula is pretty easy. I just got to multiply the 3 together. 5 centimeters times 2.4 centimeters times 0.6 centimeters, and I get just about 7.2 cubic centimeters. Now that one has been done for you on the sheet. All right. You are going to have to do the calculations for the metal bar. Now the measurements have been put on there for you, so you don't have to do the measuring. But again, we're going to have a length which is going to be about 8.8, a width which is going to be 2.5, and a height that's going to be just about, again, about 0.6 there. So you'll just need to do your math for it. Next, we're going to do a golf, you'll need to calculate the volume of the golf ball mathematically. To demo this, I'll do the ping pong ball. All right. To get the radius, the formula here says 4/3 pi r cubed, r being the radius. The radius of a circle, if you're familiar, is kind of halfway between. Now, as fate would have it, it's not easy to necessarily do to do a radius, but a lot of times what makes it a little easier is if I do the diameter, the full distance between, and then I just cut that in half. For my ping pong ball, the diameter is about 4 centimeters, which means my radius should be 2 centimeters. Radius will be 2 centimeters. Well, if I follow my order of operations in math, I know that I always want to do my exponents first. That's going to be important in getting the correct answer. So I'll plug in my numbers. I've got 4/3 times pi, which is going to be 3.14, times 2, and I'm cubing that number. Take out my calculator. 2 cubed is just 2 times 2 times 2, which of course is going to be 8. To multiply by 4/3, I'm going to multiply by 4, and then divide by 3, and then I'll multiply by pi, which is 3.14. And I get 33.49, which will round to 33.5. And again, that one is given to you on your sheet. Now you're going to need to repeat that, but instead of using the ping pong ball, you're going to do it with a golf ball. Now it gave you a radius. Unfortunately, the radius that is written on there is incorrect. So please change the radius for your golf ball to 2.1 centimeters. We tried to alert you to that as well in the sheet. But when things got transferred over, I deleted a few items, unfortunately. You got the radius of a marble instead of the radius of the golf ball in there. So please change that radius that says that, I think the radius says 0.9 on your assignment sheet. Change that to 2.1 and do the calculations with 2.1. The last formula is going to be the volume of a cylinder. And we're going to use the screw to do this one. Now, as you might notice, a screw is not going to be a perfect cylinder, okay? And that's one of the challenges we have when we start to determine, well, what do we think is the better measurement using for volume? Doing water displacement or using our geometry formulas. Sometimes we have what are called regularly shaped objects, like this ping pong ball, pretty perfect sphere, and it works pretty good to use the geometry formulas. Other times we have a little more irregularly shaped objects. Doesn't work quite as well, but we'll see how they come out. First of all, I want to find the radius. Formula is pi radius squared times the height. The radius of my screw. The diameter looks to be just about 0.5 centimeters. That's the diameter, so the radius is going to be half of 0.5. For you math wizards, you already know the answer is going to be 0.25. 0.25 centimeters. I'm going to have to square that, multiply it by pi, but then I also have to multiply by the height, or the kind of the length of this screw. And if I plug this in here, where you can see it a little bit better, looks like we're right about 5.3 centimeters. Times 5.3. Now I'll plug into my calculator. I got 0.25 as my radius. I'm going to, again, do what I got to do my exponent first. So I'm going to multiply that by 0.25. Multiply that number by pi. And then I'm going to multiply that number by 5.3. And I get just a little bit over 1. If I actually round it to the 10th place, it's actually going to be 1.0. And that would be my volume of the screw. Now there are calculations that you need to make then as we go through. Again, a number of them have been done for you. You'll have to calculate fill in those numbers that we did together. Also, then you're going to have to calculate the volume of the metal bar, the golf ball, and the rubber stopper given that data. Again, please remember to make this change on the radius to 2.1 for the radius of the golf ball. You also then are going to have to calculate the density for all of these objects. The domino you see has been done for you, but you'll be required to calculate those. And again, it's kind of like a matching or multiple choice question in the sense that you'll have a list of possible solutions down here at the bottom, and then you'll be asked to drag them to the appropriate box to get the correct answers. Good luck, and have some fun.